Welcome to TFR Let's Talk. I'm your host, Swapnil Bharti, and my next guest is Brian Fox, CTO at Sonatype. Brian, it's great to have you on the show.
Yeah, thanks for having me.
This is the first time we're talking to Sonatype, so I would love to know a bit about the company itself. What do you folks do?
We have a long history of providing developer first tools, helping them better leverage open source components. It starts from the company's founding when we were working on the Apache Maven build system. We've run the repository of the world's open source Java called Maven Central since long before the company's founding, and that gives us a really interesting perspective on the supply chain at large.
Right. And I love that you use the term open source supply chain, because if you do look at open source, it doesn't matter how somebody is using it. You may be just consuming it, you may be using it in your project, or you may be a vendor who is packaging a lot of open source technologies and shipping it out to your users, or a cloud provider which is running on the service. The thing is that there are so many moving parts that sometimes we don't even know what is running in there. So can you talk about the importance of knowing what is there, so that you have, just the way we look at recipes, we should know what is in the food, or assembly line for a car, we should know. So talk about the importance of understanding what's in your what code you're running there.
We've come a long way as an industry. In 2010, 2011, I think people were in denial that they were using open source. We talked to a lot of companies. I think they thought, well, we're not using Linux or OpenOffice, so we have no open source. But the reality is, every modern development language is that these days, you can't really be innovative unless you're leveraging the open source. You certainly can't keep up with the competitors writing every single line of code like I used to do when I started my career. And so, so much of that happens from bottoms up that it's only been in the last 5-6 years, I think, that companies have started to figure out that there are risks in that, in allowing the developers to just choose anything they want without really paying attention to the implications. The first things people started to worry about were the open source licenses. They were afraid of getting sued over GPL and AGPL copyright violations. But then later, as we saw with additional vulnerabilities in struts and other things like Heartbleed and Shell Shock that came along, people started to generally, pay attention to these problems. And we've seen quite an evolution in the supply chain problem. I'm sure we'll get into that a bit more. But, the biggest part of the problem is that so many companies don't have the ability to produce a bill of materials. So if you don't even know what's in your software, how do you know what vulnerabilities you need to be responding to? When struts first became a big problem back in 2013, we saw companies that were like literally, scraping their disks on their production system looking for things that said struts in the file name, because they literally had no other way to understand what was going on in their organization.
No matter what you do, there is open source code in there. Not knowing what's running there is actually dangerous. And situation is something similar if you look at just container world, right? What you do is you just grab a container from public repository, but you don't even know what is in there. Now, there are a couple of challenges. One is, of course, security, because you don't know where the hard link is going to. Second is that violation of licenses. You may not even know what code is there. It may contradict with your own license. So, once again, I want you to just quickly talk about from these two aspects, and why companies should, number one, know what, so that they have a very holistic view of the supply chain, just not from this perspective, but let's say you're a small company, you may get acquired tomorrow, then that will become a big challenge. So there are so many things that we can, but I just want to kind of emphasize a bit more about knowing what's in there to better understand supply chain.
Sure. I mean, if you're a startup, you make a great point that your acquirer will take a look at this. Significant investments will take a look at this. We've been through it, and this is what we do. And we had to go through it as well multiple times. It's very difficult later to pull those things out, especially in a deal moment. So startups have to care about it. Large companies are going to have to care about it because they're selling stuff to the government. The new executive order is requiring anybody selling to the government to be able to produce a bill of materials for them. And the reason for this is it's very hard as a consumer or even a company that's sort of a middleman that's consuming and then redistributing to understand exactly what's inside the physical goods or in the digital goods in a way that you can with the physical goods. You can always take something apart and inspect the chips inside it, but you can't see what's programmed on the chips. And that's why it's so critical to have a bill of materials, because these pieces of software are everywhere. Think about infotainment systems in the modern car. Half of them run Android. Android is based on Java. All of that stuff is built on top of open source. Half of the mobile phones, all the Android phones, medical devices, all these kinds of things are baking in these libraries because it makes it easy for them to produce, quality things, innovative things quickly. But if they're not sharing the downstream risk, how do you know what you're supposed to defend against? If you just pull in some software and you put it on your network, and you have no way of understanding what's inside there, you have no chance. And some of the counter examples, people say, well, if we publish our recipe list, then the bad guys will use it against us. I mean, look, if they want to know what's inside your software, they have the ability, the time, and the motive to decompile it and figure it out. If you don't know what's in your software, you might actually be the only ones who don't know. And so, it's not increasing the risk that your software gets exploited. It's really the inverse. It allows you to be able to respond, and your consumers to be able to respond. While they may not be able to swap out components to actually fix it, there may be mitigating controls if they understand what the risks are inside that black box. They can put the controls around it to help defend it. That's why you need to have that bill of materials.
Can you talk about the cultural aspect of this problem also?
It's always the humans. It's rarely the tech. It's it's the squishy things behind the machines. Yeah, the culture of getting this right is very difficult, especially in the modern organization. You see things falling into a couple of tribes. The warring tribes of this couple decades is dev and security, right? And security is trying to defend the garden and trying to reduce risk as much as possible. The challenge is, as development has become more agile, more continuous, building upon these open source things, that the practices around application security haven't really caught up with that or kept up with it. And it's leading to, in many organizations, a lot of friction. And that was something I observed very early on in the company when we were trying to help people modernize, that everybody meant to do the right thing. The goals they were trying to achieve, their objectives were correct. Their tactics for doing it were incorrect. They were creating, friction and slowing down development, these types of problems. So that we designed solutions to really help with that, because we recognize that, legal has a role to play, security has a role to play. And guess what? If development can't get anything done, the business might not exist. So you got to find a way to coexist. And so much of that is about culture, just like in DevOps and DevSecOps, getting the humans to work together. But my approach is always to kind of try and highlight the modern challenges, because I think when you see what's really going on, even a security professional who is trying to do, or who is trained to do more of the old school type of things, will immediately recognize that those approaches are not going to work. And what I mean by that is many of the new attacks that we're seeing in the supply chain are actually focused on the developers and the development infrastructure. So in a world where your application security is designed to validate the output of development and make sure that it's safe and secure before it goes to your customers, that's great. You need to do that. But it's not actually protecting the developers and the development infrastructure against backdoors that might be installed from malicious components that they've consumed, accidentally, right? And once you recognize that, and then you go back and look at your approach, you have to realize that you're missing a big part of the game. And I think the problem is just an awareness, because the market has shifted so quickly that people haven't been able to keep up with it.
Because of security issues, sometimes you have to delay the feature update or push changes to the code. Sometime, of course, you have to totally postpone it. And then you also have to, when do you want to push it? Do you want to do it on the weekend? And do you want to do it during peak hours? And another thing is that sometimes you are pushed hard against time, you end up shipping vulnerable code. And we see a lot of reports where a majority of code gets shipped, which is vulnerable. I want to touch about this one before I want to talk also about, despite being open source, developers still face challenges when it comes to open source security. But let's first talk about this aspect where you end up shipping vulnerable code because not shipping means delay, feature. time. So let's talk about that.
That's been my observation as well. Like I said, in the early days, we were trying to help companies with that. And I saw that all the time, that basically, they would play a shell game, and development figured it out and learned how to game the system. I mean, let's be honest, right? They knew that if they put the security guy in the corner and only allowed him to investigate it at the very end, that basically they were creating a false Sophie's choice kind of thing, right? Where, either we ship this thing now and you accept the risk, or, we take a month delay or something hyperbolic like that. I saw that so much. And that's what led to us really rethinking, how can we help this? And it starts by giving that information early and often up to the developers when they're picking components, when they're doing development. Updating those components is often a no-brainer when it's done at the right time. And so if you can do that and it becomes just part of your natural development planning process, you reduce those unplanned, emergencies where something that should have been known weeks ago is only discovered just before release, and you don't have to have that fake choice, right? So we've seen that for a long time, and really it's just counterproductive. It's wasted energy within an organization that should otherwise be put to better serving their customers.
But the fact is that this is not something we want to do on purpose. It is because, kind of sometimes, helplessness also. Okay? So because there are some challenges when it comes to security and open source. So can you also talk about some of the biggest challenges that we face when it comes to ensuring security with open source code, which leads to practices like these that you just mentioned?
Yeah, I think, coming back to the bill of materials, the biggest problem I see in so many companies is they don't even know what they have. They don't even know what they're looking for. And the other thing to recognize is that open source has dependencies too, right? They like to say it's turtles stacked on turtles all the way down. And so in Java, you might see one direct dependency pulling in anywhere between 10 to 100 additional dependencies. In JavaScript, it's 10x that. It could be 100 to 1,000. And so even your developers are probably not aware of all of the things inside your software because they didn't pick all those things. They picked one thing. It's like when you buy a crate engine for your car. You know who put the engine together, but do you know exactly every single part, who made every part? You probably don't. That's the equivalent of what's going on. And that, it just explodes the risk because even your developers don't have that full visibility, and trying to do that manually is impossible. Especially where each time you update one of those things, it's going to drag, 10% or more of its own versions of its dependencies are going to change too. Right. So that's the biggest challenge, I think, in securing this stuff. I mean, you're dealing with sophisticated adversaries now who are very motivated. They're projected that the cybercrime industry, is more than $6 trillion this year, as compared to a global worldwide drug trade that's around $450 billion. It's not even close. When we think about how much time we spend dealing with drugs and the war on drugs, cybercrime was a bigger industry 5 years ago, and we don't talk about it much. The last quarter or so, I think it's been on the news every night because of all the attackers taking down gas pipelines and water treatment and hospitals and stuff like that. I think we're getting to that point where people are generally accepting it. But, it comes back to, if you don't know what you're looking for, how can you possibly defend against it? You just simply can't know.
If you look at the open source community, a lot of efforts are going on. Their Linux Foundation, they have, a lot of project. XPDX is a very good project for, just having, bill of material, and they have other initiative there as well. But now we are also seeing some initiative from federal government level. The Biden administration, they recently signed an executive order to kind of address some of these cybersecurity issues. And especially if you look at the recent ransomware attack, we are still underway, right? Brazil, their food packaging company, it was under attack. So the fun thing, not actually fun is not the right word, but we don't need conventional warfare. We can just shut down pipeline, shut down grid, and suddenly the whole nation will come to chaos. There'll be riots just for food and water and gas. So this is a very, very serious issue. What I'm worried about is that why we were so behind, why we did not have these kind of things in security is something which has been, as you said, around for so long. We should be living in a secure nirvana, right? Just the way cars have airbags, we don't have to worry about those things. So why not cybersecurity? So from this perspective, let's talk about the executive order. What is your take on it? It's early days. Some languages is still, debatable, but let's talk about it.
Yeah, I'm glad to see it. There was a bill that was put forth in 2014, 15, that basically was trying to achieve the same thing, and it didn't get very far in Congress, but it was passed committee. So I'm glad to see that it's finally happening, and by moving the needle on who is selling to the government, they have suppliers. All of those vendors have suppliers, so it's going to impact a large part of the commercial software. Who's not selling to the government? Those people want to, right? So it's going to make that change. The thing that I would like to see us move more rapidly towards are, focusing on automatically being able to exchange the bill of materials. As I said, so much of the dependencies trickle all the way down. If you're picking up another commercial software package and using it in your tool, and you're selling to the government, you need to have that bill of materials from that commercial thing to complete yours. And the initial requirements, as I understand them, merely require that somebody make available on their website, as an example, a list of the components in it. That's kind of the equivalent of saying, you know what, we're going to get rid of food labels on the carton. You got to go to General Mills and find out what's in their cereal, right? That nobody's going to do that. So I think we need to get to a place where we have some good standards. Doesn't have to be one standard, but a couple will be okay, that are focused on automatically exchanging that data. It's the only way we're going to be able to scale to what's happening. When you've got organizations consuming hundreds of thousands of components a year, literally just Java components, we can see it from the central repository, hundreds of thousands of components. How are you going to have a list on a PDF on your website that is anything useful for your consumers? You're not going to be able to, right? So you need automatic tooling to be able to produce the bill of materials. You need automatic ways to be able to exchange that so that you can hand those things downstream, ultimately to the end user.
You talked about it earlier, but I want to wrap this interview with this question, which is more or less about, we talked about the problem areas. We also touched upon the kind of solution area. Now I want to talk about Sonatype and look at it from the kind of solutions you are offering to kind of help users with some of these problems that we talked about.
Yeah, so we've built effectively a developer-focused control plane for managing and integrating across the SDLC. So we have the ability to help you guide your developers up front to make better choices of their components. We have the ability to actually inspect what's being built, allow you to define policies to pass, warn, fail, so you can warn the developers there's a vulnerability in one of your dependencies, but not interfere with their ability to do it, but then actually later stop the release if they've ignored that warning, right? That's what it's really about, not blocking all of the pipeline. And because of the modern threats around the malware and the unknown risk that exists in some of these things, we've even built technologies that are able to detect when the behavior of the project that is publishing things is changed, whether it's new committers or releases done in weird ways, or dependency changes that don't make sense, we can flag those as suspicious, much like a credit card company might flag an unusual transaction that doesn't fit your typical behavior. They recognize it. We're doing that for components, and we're doing that to help protect the developers and the development infrastructure, because you can't wait for the community to discover, after a week or 6 months that this component had malware in it, because you've been exposed the whole time, right? So we're focused on doing those types of things and then expanding it out to support other parts of the business, whether it's infrastructure as code or the container scanning, advanced legal capabilities. All of those things require action by developers, which is why it needs to be integrated into that developer-first control plane.
Brian, thank you so much for taking time out today and talk about this very important topic. And I would love to have you back on the show, because first of all, security is one of our core focus areas, and so much is happening in this space. So I would love to have your insights. Thank you for your time today.
Thank you. Yeah, there's so much more to cover in this area.